What is wrong?
What do you mean?
Are you ready?
Hello everyone, we're just gonna give it a few minutes and then we'll start.
Who's here? Leah. Okay, people are joining me.
What paper are we working through? We're going to do the circle geometry questions for last year's November paper, the November 2021 paper. So that's the latest one. They just released it, I think, a week or so ago. It wasn't available up until very recently. Let me just open this again. You can look at the question so long. I'll zoom in a little bit more. So there you go. That's the one that we're going to be doing. Yeah, the grade 12 one, but this is grade 11 work. You learn how to do all of this in grade 11, but then you get tested on it in grade 12. Please share with your friends if they're also in grade 11 or 12, especially if you know that they struggle with circle geometry. This is by far the most requested topic on my account since I started last year. Everyone's always asking me to go through circle geometry stuff. So please share with friends if you know that they would be interested in this. And yeah, thank you. We'll get going in a bit. Let's give it another 3 minutes or so. How has the holiday been for everyone so far? Today is my first official day on a holiday. Thank you for the likes, guys. Hello to everyone that's just joining now. Oh, I see one person shared. Thank you. There's another one now. Thanks so much. We're just going to wait another 2 minutes. I want as many people to be here as possible before we get going. It's not nice if you miss the first part of a question. This is grade 11 and 12 work. So you learn it in grade 11 for the first time. Some schools actually do some of this in grade 10, but officially it's only grade 11 work. And then you get tested on it, obviously, in your matric finals. So yeah, it's grade 11 and grade 12 work. And we're going to work through the November 2021 questions. It's question 9 and let me just check, yeah, question 10. I don't think we'll have time for more than that. But I will be going live again tomorrow on the same section. So then we'll keep going. If we get cut off before we finish this question or these questions, we'll definitely get through question 9, maybe not through all of question 10. I'll try my best. 1 more minute, guys, then we'll start. Please share this live with as many people as possible. If you have people that might be interested in this work, tomorrow I'm going to be live at the same time at 3 o'clock again. Yeah, it was a bit short notice. I only decided this morning that I would go live, so I didn't do there wasn't a lot of notice or a lot of time, so I'm hoping that people that follow me at least will get notified. Maybe this will come up on some people's For You pages. Okay, it is 3:03. I think we are going to get going. Alright guys, so like I said, firstly, welcome to everyone that just joined. I see we are now on 100 people. Welcome everyone. Hello, thank you so much for joining in your holiday. This circle geometry is definitely the most... Yes, this is recording. Okay, I'll chat for a little bit. I see your message about your friend. Yeah, so circle geometry is by far the most requested topic. That whenever I ask what do people want me to go live on, people always say for circle geometry. So yeah, I thought that I would take today, and then tomorrow at 3 I'm going to go live again and just work through some past paper questions. So like I said already, some of you weren't here. You learn about this stuff in grade 11 for the first time. At some schools, they start in grade 10. But then you get tested on all of this in grade 12. So I'm just going to work through these past paper questions. These are the latest questions that are available. This is last year's November 2021 matric final exam. It's the paper 2. So questions 9 and 10 were the circle geometry questions in this paper. And we're going to work our way back. So tomorrow we will do it. Yeah, it depends on how far we get today by 4 o'clock, but tomorrow we'll carry on, or we'll do the May-June exams, which is a supplementary exam questions. We'll work our way backwards. All right. So I am going to get going now. All right. I see some people are asking about live for grade 8. I have not decided yet. I'm just doing these 2 lives, and then unfortunately I'm going away for the rest of the holiday, so I won't be able to go live again unless I make a space some way somehow. I'll see, but yeah, no promises. Okay guys, let's get going. So when you are doing geometry, it is very, very important that you read through the stuff that's given in that little sentence. I know you are usually in a rush, you want to get going, but you really have to first kind of figure out what is going on this diagram. Another thing, this is the first time that I'm going live on this iPad, so sorry if I mess up a bit, or if I have to fiddle around with it. I'm hoping that it will work well. So, okay, let's just get used to all the information that they've given us. We're going to fill in on here. And we're also going to just kind of orientate ourselves a little bit before we start going into the questions. All right, so in the diagram, PQRS is a cyclic quad. Okay, PQRS is a cyclic quad. Now, something that works quite well is if you actually just highlight that cyclic quad, right? If you have a pen or pencil, and in matric finals, I don't know if you guys are aware of this, but you get an answer book, so you can actually make any, you can fill in any information that you want on the diagram. You don't have to redraw the diagram. Okay, so it is quite useful if you can see that on the picture. All right, so what do we know about cyclic quads? We know, firstly, that opposite angles add up to 180, right? So if we know that that's 93, we can get that angle S1 easily by saying 180 minus 93, and then these two will also add up to 180. All right. Another thing that we know is that when you have a cyclic quad, the exterior angle of that cyclic quad. So when I'm talking about exterior angle here, I'm talking about this angle S2 and S3 together. That is an exterior angle, right, of the cyclic quad. Now that is supposed to be equal to the opposite interior angle. So that means that just by knowing that it's a cyclic quad, right? Let me rather do this. Just by knowing that PQRS is a cyclic quad, I can already tell that angle S2 and S3 will be equal to 93 because of exterior angle of cyclic quad. Okay, we're going to keep that in mind. We might use that later on. Okay, then they're saying PS is produced to W. Now, guys, what this actually means when they say that, they are basically saying that PS is just extended to point W. So they're actually telling you that PSW is a straight line. All right, when they say that PS is produced to W, they're telling you that this is a straight line. So you can use like angles on a straight line and so on. Let's see what else. TR and TS are tangents to the circle. All right, so TR is a tangent and TS is a tangent as well at R and S respectively. Now, guys, what do we know about two tangents that come from the same point outside the circle? We know that those tangents are equal in length. So I'm going to fill that in as well. All right, we might be able to use that. Angle T is 78 degrees. They did fill that in, and angle Q is 93. They filled that in as well. Guys, sometimes they trick you and they give information here that's not filled in on the picture. So it is very important that you do that. And another thing about circle geometry is you really have to know your theorems. I'm not talking about the proofs of the theorems, but you have to know all of those rules, right? If you just jump into a question and you don't know all your rules, you are going to feel a bit lost and you might miss important things. Like, for example, if you don't know that two tangents from the same point outside the circle are equal, then you wouldn't be able to answer the first question. All right, and unfortunately, a lot of the rest of this question relies on knowing that one theorem. So it really is important, guys, that you know your theorems really well. I do have a grade 11 geometry summary note on my Google Drive. If you click the link in my bio, you can go look at that stuff there. I'm also working on some on the iPad now. But yeah, you really have to actually sit down and take the time to memorize all of those theorems. It will really make this section much easier for you. Okay, so let's go to the questions now. For 9.1, they're saying, give a reason why, so they're wanting the reason why ST, I almost said angle ST, but ST is a line, right? Why ST is equal to TR. Now guys, note that I've already filled that in because tangents from a common point are equal. All right, now this is a 1 mark question, you can see that. So the reason here is literally just the reason from the CAPS document. So the reason is tangents from common point. Okay, and there you have your 1 mark. All right, and we've already filled that in as well. If you didn't fill that in when you were reading through all of your information here, then obviously now they're saying give a reason why ST is equal to TR. Then you would say, oh, good, okay, let me fill that in. Guys, it's so important that you fill in everything that you're calculating and also everything that they are giving you. So if you didn't know this reason, when they're saying give a reason why ST is equal to TR, guys, they're telling you that ST is equal to TR. So even if you don't know what the reason is, fill it in. This now becomes given information. And it's important that when they give you information, you can use that even if you don't know how to get to it. All right, so that is given information. Very important. You're going to have to use it later on. That's another thing about geometry. Just the geometry questions in general. It counts for analytical geometry as well. Often you need to use the information that you are finding in 9.1, for example, in your 9.2 calculations. So if it's a question like this, they're saying give a reason why, and you don't know what this reason is, you at least now know that ST is equal to TR. Okay, next question, 9.2. Now they're asking us to find the sizes of two angles here. So they're saying 9.2.1 or calculate giving reasons. The size of 9.2.1 is now asking for S2, which is this angle over here. Right? They're wanting that angle. Now guys, let's look back at what we found in 9.1. Remember, what did I just say? The information or the question after usually relies on information that we find in the previous question. I'm actually just going to move this up a bit because I have some space. All right. Sorry about that. So now we need to find S2. And guys, we're probably going to have to use the fact that these two sides are equal. I can't turn off the comments, but you can swipe to the right and then the comments should disappear. Then you should not be able to see them. Now guys, if we're looking at this triangle, right, the fact that these two sides are equal makes this an isosceles triangle, which means that S2 is going to be equal to R2. Okay, now this is a question that is asked very frequently where you have one angle of a triangle, an isosceles triangle, and they are asking you to get one of the other two angles. Now guys, what you need to understand is that these two angles are equal. So if I say 180 minus 78, that will give me these two angles, what those two angles are equal to together. All right, I'm going to write that down now. So that will give me the sum of S2 and R2. Obviously, I just want S2. So what I'm going to have to do then is divide that sum, right, S2 and R2 together. I'm going to have to divide that by 2 in order to get the size of S2. Okay, so I'm going to write this down. So 9.2.1, angle S2. And you can do this in more than one step if you want. I usually just do it in one step. So I'm going to say 180 minus 78 over 2. All right, now you can obviously use your calculator for this, but 180 minus 78 is 108, and then 102, and 102 divided by 2 is 51 degrees. I see someone put the answer in the comments. Thank you for that. All right, so the answer is 51 degrees. But guys, this is geometry. We know that we have to put in our reasons. Okay, now this, we have two reasons for this. The fact that we're saying 180 minus is because this is a triangle. So we have to say angle sum in triangle. And then what is the reason when we are using an isosceles triangle? Guys, you can't write isosceles triangle, okay? They don't accept that. You have to say angles opposite equal sides. We see that these two are the equal sides. So the angles that lie opposite those sides will be equal. That's where that reason is coming from. Okay, so you do have to add that as well. Angles opposite equal sides. Just let me know if my writing is too small. I can always zoom in a little bit. All right, so there we got S2. That's 51 degrees. Now, guys, what I was saying earlier, it's good if you actually go and, sorry, let me just change this. I want to erase that, but let me, okay, let's see if I can do it. Oh, okay, that's good enough. All right, so S2 is 51 degrees. So there we have that value. So fill it in, guys. Very important. Interior angles of triangle. I think that's accepted. I'm actually not 100% sure now. You can take a look at the CAPS document. I did post it in my Google Drive, but you can also just Google. It's actually, sorry, it's the exam guidelines for grade 12. I did post a copy of that on my Google Drive. You can go take a look. All the reasons are there. I always say angle sum in triangle, but I think interior angles of a triangle is correct. I'm not 100% sure now. Okay, 9.2.2, they're now asking us to find S3. All right, so let me just take this dot away because we're done there. We now need to find angle S3, this one over here. Now, guys, the fact that I filled in that this whole angle should be equal to that whole angle at the beginning makes this so easy now because I know that S2 is 51. So 51 plus S3 has to be equal to 93 degrees. Why is that again? They told us that PQRS is a cyclic quad. And we know that the exterior angle of a cyclic quad, which is S2 and S3 together, right, these two together, should be equal to the interior or the opposite interior angle. I'm going to say that again. The exterior angle of a cyclic quad is equal to the opposite interior angle. So S2 and S3 together should be equal to 93. All right, now you can write this in less steps. I'm just going to write it out in full so that I don't lose anyone. So we know that S3, which is the angle that we're looking for, plus 51 degrees should be equal to, what was that, 93? Yeah, 93 degrees. And the reason there is exterior angle of cyclic quad. Guys, you can't just say exterior angle of quad. You have to say exterior angle of cyclic quad. That's very important. All right, so is the answer 42 degrees? Yes, thank you. So S3 is then 93 degrees minus 51, which you don't have to show. You can actually just go straight to the answer. So that is 42 degrees. Okay, we can fill that in, but this was actually the last question, so we don't really need to. But there we go. That is the answer. Okay, are there any questions on question 9 in general before we move on? This was the whole of question 9. I'm just going to zoom out a bit so that you can see all of it. I will post this note to my Google Drive when we are done with it so that you can see the solutions. So if you don't have access to this document now, the actual past paper, then you can go take a look at my Google Drive later on. Okay, let's go on to question 10. Now, guys, question 10 was a bit more difficult. Question 10 is not necessarily in terms of numbers. We can see straight away that there's an X over there. All right, so question 10 was a bit more on the tricky side. So they're saying, again, there is a little paragraph. We need to read through everything. We need to make sure that we know what's going on before we jump into the question. Okay, so they're saying, in the diagram, see there's a lot going on. They're saying B, E, and CD are diameters of a circle. All right, so that's interesting. BE is a diameter, and CD is also a diameter, okay? Having M as center. So that's strange, guys. They don't usually use M as the center of the circle, right? It's usually O. In this case, it's M. Chord AE is drawn to cut CD at F. Okay, so that sentence is not really giving us any information that we can't see here. They're basically just saying that AE intersects or cuts CD at point F. Okay, we can see that. AE is perpendicular to CD. We can see that as well. And then they're saying let angle C be equal to X. Okay, that was all filled in. Question 10 was in your term 1 test. Interesting. Okay. Right, so let's see. What are they saying here? Give a reason why AF is equal to FE. So guys, like I said earlier, even if you don't know what the reason is, they're telling you that AF is equal to FE. So fill that in on your diagram, right? Okay, AF is equal to FE. I do have a YouTube channel, yes, it's Miss Hanekom. You can just click the link in my bio and it is there in my link tree. Okay, give a reason why AF is equal to FE. Now guys, this is a theorem that actually isn't used all that often, right? It's a bit tricky. Sometimes you forget about this one. This is one of the only, or this is the only like proper theorem that this one and its inverse that works with lines in a circle, with chords and not actually angles, right? Do you remember that when you have a line from the center of a circle, so from M in this case, that is perpendicular to a chord, then it bisects the chord, then it cuts the chord in half. And that is exactly what's happening here, right? MFC, this line, is from the center and it is then perpendicular to chord AE. So that is why AF is equal to FE. Okay, so this answer here is, let me just zoom in a bit, line from center perpendicular to chord. All right, there we go. I'm just going to move this picture up slightly because we have a bit more space now. I wasn't sure of how much space I was going to use. Okay, next question. Cool. So we filled that in. All right, that's the reason there. It's also just a 1 mark question. Determine giving reasons. Of course, we always have to give reasons in circle geometry. Wanda, that could be because of your domain that you're working from. I know if you're working with like a school email address, then often it doesn't allow you to download from someone else's Google Drive. So maybe see if you can log into someone else's email address, someone else's account, and then download from there. Yeah, that has happened. And often if people even request access and I try and give it access, it then says that your administrator has not given you, permission to download stuff off of my Google Drive. So I'm sorry about that, but unfortunately there's nothing I can do about that. Okay, determine giving reasons. The size of M1 in terms of X. Okay, so now we're looking for M1 here. Now guys, in terms of X, they're not saying that we have to solve for X. They're saying in terms of X, all right? That means that our answer is going to have an X in it. Often, I don't know if it's still the case when you get to matric, but often when people see that there's an X somewhere, they just think, I must solve for X. And then they just want to make things equal to 0. All right? That is not the case here. When they're saying in terms of X, that means that that didn't go straight at all. In terms of X, there we go. That means that your answer is going to have an X in it. Okay. So now we need the size of M1. Now guys, what is important here is now we're looking for the size of an angle. Whenever that is the case, please look and first see what chord or arc. Remember, a chord is a straight line, an arc is a part of the circumference. Which arc is subtending that angle, right? Which arc is subtending that angle? If we look at angle M1, it's coming from points C and E. The lines from C and E are joining up. They meet at M1. All right, so we say that CE, arc CE, subtends angle M1. Now you're going to check, is there another angle that is subtended by CE? Let's see, we have another line from C and another line from E going and meeting up at A1. All right, that's interesting. I actually don't want to put a dot in there because they are not going to be equal. right? This one, A1, is also subtended by the same arc. What we need to recognize is that A1 is at the circumference, M1 is at the center, and we know that an angle at the center is double, 2 times the angle at the circumference. So guys, is there a way for us to find A1? Because if we have A1, we can just times that by 2, and that is then M1, right? A1, that will help us to get to F1. Do we notice this triangle here? Let me highlight it quickly. I can take the highlighted bit away just now. Do we notice that triangle there? Triangle ACF. Triangle ACF. Guys, that is the triangle that A1 is an angle of. And we have the other 2 angles in that triangle. Isn't that useful? So I can just say to get A1, I'm going to do 180 minus 90 minus x. Simplify that. That will give me A1. Then, because A1 and M1 are subtended by the same arc, right? Arc CE. Because they are subtended by the same arc, but A1 is at the circumference and M1 is at the center, I can then take whatever A1 is and just times it by 2, and that will give me M1. All right, so let's do that. A1 is equal to 180 minus 90 minus x, right? I'm doing angle, sum, and triangle in this triangle up here. All right, that's 90, that's x, so that's what I'm doing to get A1. The reason is angle, sum in triangle. And when you simplify that, guys, 180 minus 90 is 90. And then minus x. Okay, so that's A1. And what did we say? M1 is going to be double A1 because of angle at center. They're subtended by the same arc. All right, so therefore, M1 is going to be 2 times, you don't have to put this step in, but I'm just writing it in so that no one feels lost. 2 times A1, right? 2 times 90 minus x. I'm going to simplify that now. And guys, unfortunately for this one, you have to write that whole long reason. I know it is a mission, but we have to stick to the rules, unfortunately. So angle at center equals 2 times angle at circumference. Okay, there we go. Angle at center equals 2 times angle at circumference. And now, guys, this is going to be easy to do. 2 times 90 is 180, and 2 times negative x is minus 2x. Right, so that is M1. Now, what I'm going to do, I'm just quickly going to erase all of this highlighted stuff here because I actually want to fill in those angles. I'll put in that little line just now. We might need to use this information. Okay. Let me also, oh, sorry, I knocked the ring light. So take that away. So this angle is 90 minus x. Oh dear, sorry. This angle is 90 minus x. And that angle is now 180 minus 2x. Okay. Again, as soon as you work something out, you fill it in on your diagram so that you can use it again. All right, let's look at 10.3. Now, guys, 10.3 is a difficult one, which I'm going to use something on this tablet that is difficult to do when you are doing it manually on a piece of paper. But hopefully when you see how I'm going to do this, it will make sense. This is also quite a common question that they ask, and one that people usually don't get right, unfortunately. So they're saying, prove, giving reasons, that AD, now AD is drawn in on this diagram. Okay, I'm just going to highlight that quickly. Let's make it green again. AD. Okay, we need to prove something about AD. Is a tangent to the circle passing through A, C, and F. A tangent to the circle passing through A, C, and F. Now, guys, A, C, and F are these points here. Obviously, we don't currently have a circle going through those 3 points. So that is something that you need to visualize, okay? You need to be able to visualize a circle going through those 3 points. Now, because of the magic of this device that I'm working with, I can actually draw a circle and let it go through those 3 points. Let me just try line it up quickly. And then you will be able to see a bit more clearly what they're actually talking about. Okay, there we have a circle going through those 3 points. So guys, this is the circle that you need to be able to visualize. They didn't tell us anything else about the circle. They didn't say, for example, that AC is a diameter, but do we see that it actually would be a diameter, right? Because that angle at F, angle AFC, is a 90-degree angle, right? And only a diameter can subtend a 90-degree angle at the circumference. Okay, so that's something quite cool. They're not asking us about that, but we could possibly use that. But guys, what are they asking us about? They are saying, prove that AD, this highlighted line here, is a tangent to this circle. Now guys, if they're asking you to prove that a line is a tangent, you're going to usually have to work with tan-chord theorem. All right. What does tan-chord theorem say? Tan-chord theorem says that the angle between a tangent and a chord, right? So I'm going to choose a different color here. Let's use, let me just get a different color. Let's use blue. The angle between the tangent, now in this case the tangent would be AD. That's the line that they're asking us to prove is a tangent. All right, so the angle between the tangent and a chord. Now guys, the chord that we have here is AF. Do we see that? That's the circle that you would have to visualize, okay? So the angle between the tangent and a chord, all right? So A2 is what they're talking about, that angle, will be equal to the angle subtended by that same chord in the alternate segment. So on the other side of the chord, do we see that this chord subtends angle C? Right, so if AD is a tangent to this circle, then A2 would have to be equal to angle C. That is what we're going to have to try and prove, guys. I'm going to go through that again because a lot of people struggle with this concept. And like I said, it is a question that comes up often, okay? They're saying prove that AD is a tangent to the circle through A, C, and F. Okay, so I've drawn that circle in there, but you need to visualize it. But guys, you can also just take a pencil and just kind of freehand it. Okay, it doesn't even have to look like a circle, just so that you can get a bit of an idea of what you need to try and prove. Now, what I was saying is if they're asking you to prove that a line is a tangent, look for tan chord. Okay, so we're going to look for tan chord. So here, the angle between the tangent AD and the chord AF is A2. And if AD is a tangent, then that angle between the tangent and chord will be equal to the angle subtended by that chord AF in the alternate segment, which is angle C. All right, so that means that A2 will have to be equal to angle C, will have to be equal to X. So that is what I'm going to have to try and prove. In order to prove that AD is a tangent, I need to prove that A2 is equal to C. Okay, now let's just zoom out a little bit because there's a lot going on there now. I need to somehow prove that A2 is X. Now guys, let's take a look again. We know that A1 is 90 minus X. Okay, we know that. So if I can get this whole angle, A1 and A2 together, I can just take what this angle is together and minus A1, and hopefully that will equal X. So Jared Pillay is saying angle A1 and 2 is equal to 90. Absolutely correct. Why is angle A1 and A2 together equal to 90? If we're looking back at the original circle, the big circle, they said that CD is a diameter of this circle, right? CD is a diameter of this circle, and a diameter always subtends a 90-degree angle at the circumference. So this angle over here is 90 degrees. A1 and A2 together is 90 degrees. Absolutely correct. Michaela, sorry, you're saying angles in semicircle? 100%, that is the reason. Okay, so we're going to say angle CAD, all right? Or you can write A1 plus A2. Guys, it is actually easier if you just work with the numbering, the little numbers that they've given you, all right? I mark matric finals, and often it's just so much easier to mark if you've actually used the little numbers that are written there. They are written in there to make it easier for you. Okay, but CAD is also correct. A1 plus A2 is 90 degrees, angle in semicircle. So now to get A2 on its own, I'm going to say 90 minus A1, and that is going to be equal to X. All right, so let's write that down, guys. Zoom in a bit again. A1 plus A2 is equal to 90 degrees. Angle in semicircle. I think you can also write angle subtended by diameter or something like that, but angle in semicircle is the shorter one, so I prefer that one, but it doesn't matter. If it's in the CAPS document, you can write it. Okay, A1 plus A2 is equal to 90. So now, to get A2, we're going to say 90 minus that whole angle A1. So then we're going to say A2 is equal to 90 minus A1, which is 90 minus x. Guys, it is important that when you are subtracting something, an angle that consists of two terms, more than one term, you have to put it in brackets. Okay, that's very important. So if we work that out, we're going to have 90 minus 90, right? And then negative times a negative there is a positive. You can leave out this step. You can go straight to the answer, which is x. All right, so therefore, we've proven what we wanted to prove. A2 is equal to angle C. Remember, we're trying to prove that AD is a diameter, and if AD is a diameter, then A2 will have to be equal to angle C, all right, which is X. So that is important. Okay, so therefore, AD is a tangent to circle ACF. And guys, the reason for this is converse tan chord theorem. When you are using tan chord theorem to prove that something is a tangent, right? When they're asking you to prove that it's a tangent and you checking whether tan chord theorem works, you have to put the word converse there. Okay, if the word converse is not there, you're not going to get that mark. That's very important. Okay, so tan chord theorem is when they've told you that it's a tangent and you're just using that to work out an angle. If you have to prove that something is a tangent, then you must write converse tan chord theorem. Okay, now the last question. But guys, this was quite a tricky one. There are loads of examples of this type of question in all sorts of past papers. So if you struggle with that concept, you can always try and do a few more, all right? You will be able to find loads more. All right. 10.4. Someone said that they came late. Yes, this will be on my YouTube. I'm going to post it tomorrow. Okay, Jared, thank you, and thanks for your input. This paper, you can just Google NSC Mathematics past papers, and you will be able to find them. They have a whole list of all the years' worth of papers, and they have like lots of different subjects. I am on YouTube. Yes, if you click the link in my bio and you scroll down a little bit, you'll see that there is a link that says YouTube, and that will take you straight there. Okay. Now, guys, 10.4 was a question that really threw a lot of people for a loop because it had a theorem in that is taught in grade 10, but they never really focused on again later on. So later in the year, I don't know if any of you have done it yet. If you are in matric, later in the year, you're going to do Proportionality Theorem, Prop Theorem, which is almost like the parent theorem of Midpoint Theorem. In grade 10, you learn about Midpoint Theorem, and then in grade 12, you learn about Prop Theorem, and Prop Theorem almost like replaces Midpoint Theorem in a way, but in 10.4, and obviously if you haven't done Prop Theorem yet, then you can't use it in this question. By the end of this year, all of you will have done it, obviously because it is in the matric syllabus, but for today, we're going to go over Midpoint Theorem again, because Midpoint Theorem actually is what you used to solve this question. So I'm going to go back up to the diagram and just clear it up a little bit, just so that we can fill some stuff in, because I'm going to highlight something here. Okay, so I just want to move the circle to the side, actually. Let's see, do I have to? Can I tap it? Was it shapes rather? Yes, there we go. Okay, I just want to move that circle there. All right, I'm going to take away this, oops, sorry. Okay, there we go. I'll get used to this iPad soon enough, I'm sure. I want to take away that highlighted bit. I can put back this X and stuff, but we're not actually going to need it now. Let me not write that. So on the 2, sorry. Okay, that was X. All right, now they're saying in this question that CF is 6 units and AB is 24 units. Calculate, giving reasons, the length of AE. Now, guys, AE, right, is this length over here. Okay, so that is what they want. They want AE. So I'm just actually going to take away this 90 minus X as well. And I'm just going to go over this. Let's see if I can go over this line. Sorry, that is very wobbly. Let's see if it straightens it nicely. There we go. Okay, so we're trying to find AE. They told us that CF, I forgot now again, CF is 6. All right, that length there is 6. Now, guys, surely we can already think, I mean, that kind of looks like a Pythag thing. Maybe, maybe not. We'll see. Okay, and then AB is 24. So AB is over here. This one is 24. They are wanting AE, right? They're wanting this whole side. Now, guys, I'm going to highlight this whole triangle so that you can see something. And this was really like the problem-solving question, one of the problem-solving questions in this paper. Quite difficult to do, but hopefully once I've explained it, it will make sense. If you can remember midpoint theorem from grade 10. Okay, I'm just highlighting those pieces there. Hopefully we see that triangle there. Now, guys, if we said at the start, right, that if is the midpoint of AE. We didn't say it in so many words. They asked us to give a reason why AF is equal to FE. All right, now if AF is equal to FE, that means that F is the midpoint of this line, okay? Then, if we're looking at M, in the beginning, they also told us that BE is a diameter of the circle. Now, guys, if M is the center, right, and BE is the diameter, that means that M is also the midpoint of this line, right? So that means that these two parts are also equal to each other. ME is equal to BM, right? Because M is the center of the circle and BE is a diameter. Now, guys, do you remember from grade 10? I should have taken out this 180 minus 2x. Okay, I'm just going to do it like that. From grade 10, you learned that if you have a line, if you have a triangle first, right, then you have a line going from the midpoint of one side of the triangle to the midpoint of the other side of the triangle, which we do have here, right? Maybe I should write the midpoint theorem down on the side. Midpoint theorem. Now, there may have been other ways of doing it, but there actually weren't other answers on the memo, right? And this was definitely the shortest way of doing it. You might have been able to find another way to do it, and that's fine, but let's just go over this, because if this came up in last year's paper, it could very easily come up in this year's paper again. All right, so midpoint theorem, a line from the midpoint of one side of a triangle to the midpoint of another side, right? And that is what we have here. We have F is the midpoint of this side and M is the midpoint of that side. And FM, this line, is from the midpoint of one side to the midpoint of the other side, right? A line from the midpoint of one side of a triangle to the midpoint of another side, FM in this case, is parallel to the third side and half the length half the length of the third side. I almost said first side. And half the length. All right, so that means that these two are parallel. That's not really that important in this case, but I mean, you never know. But also half the length. Now, guys, they gave us this length, all right, which seems way out if we're trying to get AE, okay? They gave us this length here. That means that this length is 12. Okay? Now what we can do, what do you guys think? Do you have any ideas? I'm going to write that down so long. What am I saying? Thank you. Fm is equal to 12 units, and the reason there is midpoint theorem. All right, half of 24. Yeah, this was a hard question. Not all of the questions are like this, and this was the first question in years that actually required midpoint theorem, but I am worried that because this was given last year, it might be given again this year. All right, so let's take a look. Now, what we found here is that essentially when we get this 12, right, we have that 6. Do we agree that CM is a radius of the circle? CM is a radius, all right? So if that is 12 and this one is 6, then that means that the radius is going to be 18, right? 12 plus 6. Okay, so you need to actually look at this radius. First, recognize that it's a radius, which is also not that easy because there's a lot of stuff going on. So CM is 18 is the radius of the circle. Now, guys, isn't ME also a radius? Right? ME is also a radius. So ME is going to be 18 as well. Okay, let's write that down. Therefore, ME is equal to 18 units. And the reason for that is radii. Okay, so now we have 12 and we have 18. And guys, isn't this a right angle triangle? We have a 90-degree angle there, right? So this is also 90 degrees. This is absolutely a right angle triangle. So that means that we can now actually work with Pythag, or actually we can work in this big triangle here. That would actually be quicker. It doesn't really matter. If you are working with Pythag in this triangle, you'll use 12 and 18, and then you'll get FE. Now, because they're asking for AE, you would just then times that by 2, right? Now, if you are working with 18 here, that will also be 18, meaning that this whole length is 36. And guys, this is also a right angle triangle. I think did we say already that A2 and A3 together is 90? I don't think we did. Let me see quickly. We said A1 and A2, but guys, because BE is also a diameter, right, of the circle, that means that A2 and A3 also together is 90 degrees. Okay, so we would have to write that down. So what would you guys prefer? Working in the small triangle and then doubling it, or working in the big triangle and then you get your answer for AE straight away? Yes, angles in semicircle, exactly. You would have to write down that reason. What do you guys prefer? Small triangle or big triangle? Small and doubling it. Cool. Let's do that then. Okay, so we have 12 and 18. Let me just see, sorry. 18 is the hypotenuse, right? So we're going to have to say that FE squared is 18 squared minus 12 squared. Sorry, so you guys are saying big now. You can obviously do big. Okay, so FE squared, but I'm going to go with the first answer that I saw, is equal to 18 squared minus 12 squared. We have to write Pythagoras. That is obviously important. Guys, please, I don't want you to lose marks. It's so sad. Sometimes all the working is correct, but there are no reasons. And then people obviously lose marks. It's not nice to see when you're marking. Okay, so that is FE squared, which is 180 if you work it out. So FE is then the square root of that, which is 6 root 5 units. Or you can write it in decimal form. All right, I'm just going to leave it like that for now. So therefore, AE, just go back up to the diagram so that everyone's with me. We've now found that FE is 6 root 5, All right, so 6 root 5 and 6 root 5 together is going to give me 12 root 5. Okay, so AE is going to be 12 root 5 units. You don't need a reason for that. We said already earlier in the question that AF and FE are equal, so that would be fine. Okay, and that was it, guys. I'm just going to scroll through the comments quickly and just check whether people ask questions. I'm just zooming out in case someone maybe wants to take a screenshot of this. That is the whole question, and you can zoom in. But guys, I will put this on. Yeah, you can say proved above if you want to. Yeah, it was actually given. They actually even said there that AF is equal to FE. I just want to see some comments here. What grade is this? This is matric, but you learned this stuff in grade 11 already. Okay, I'm just going up, guys. I just want to make sure I didn't miss any questions. Yeah, there are lots of apps that have past papers on. I used to use one last year, actually. I can't remember what the name of it was now. I think just NSC past papers, yeah. So this is last year's exam. This is the 2021 November one. So yeah, this is the latest one that's available. Okay, guys, let me just check because my phone tends to overheat. Sorry. It's still okay. Okay, I think I'm going to move on to the next one, which was the May-June 2021 paper, and we'll just do the first. These are all 2-mark questions, and then there's a 4-mark question, so maybe we can get through a whole bunch of these. Okay, so this is the SUP exam. All right, yeah, 10.3 is always challenging, and then if there's a 10.4, that's also usually challenging. The last few questions are normally difficult. So guys, if you didn't understand that last question now, I don't want you to feel bad, okay? It was meant to be difficult. It's definitely not supposed to be an easy question. All right, so now this is the second latest paper that is available, the May-June exams. So these are the ones that were written last year, so the SUP exams, essentially. There is almost like a rumor. Oh, sorry, I kicked the thing now. There is a rumor that the SUP exams are more difficult than the end-of-year exams. I don't think that's the case, really. The only thing is that the SUP exams don't necessarily follow the same kind of layout as the end of year exams. If you guys have worked through a couple of November exam papers, you should notice that they usually follow the same kind of layout. They ask the same type of questions mostly. The problem solving things usually are different, obviously, but the rest is quite similar, where obviously the May-June exams are basically completely different. So people struggle with that often. Often they just work through November exams and then they get to the May exams and it looks completely different. Okay, so question 8. In the diagram, MP is a diameter, all right, of a circle centered at O. Now guys, we've worked with diameters a couple of times now, and we know that a diameter subtends a 90-degree angle at the circumference. Hopefully we can see immediately that angle R, angle MRP, right, MRP, will be equal to 90 degrees because of that. And if you notice that, you can put it in so long, okay? We might have to use that. MP cuts the chord, MP, okay, cuts the chord NR at T. Cool. Radius NO, okay, that's a radius, and chords PR, MN, and MR are drawn. Okay, they're just telling us that they've drawn those chords, radii, or radius, and then chords, and then they're saying that angle R1 is 69 degrees, that was filled in. Okay. Determine giving reasons. The size of the first question is asking us for R2. Now, guys, we've already filled something in that's going to make this question very easy for us. We know that R1 and R2 together is 90 degrees. So to get R2, we're going to say 90 minus 69. Okay. And if you want, you can actually do that all in one step. So I'll show you now. You can say R1 plus R2 is equal to 90 degrees. Angle in semicircle, and then say, okay, so R2 is going to be 90 minus 69 degrees. You don't have to write a reason for that because that was given. Okay, so that is going to be 21 degrees. Or if you want, you can do that all in one step. So you can actually leave out this first step. You can just say R2. You can even actually just write the answer of R2 if you want. R2 is equal to 90 minus 69 equals 21. But what is important is that you have to have that reason. Okay, even if you leave out this first line where you're saying R1 plus R2 equals 90, they can see the 90 there, right? If you didn't write that, we can see the 90 degrees there, but you have to say angle and semicircle. You'll lose a mark if that is not there. Okay, so R1 or R2, sorry, is 20. Ooh, sorry, the wind just blew the front door open. Sorry about that. Okay, so R2 is 21 degrees. Cool. First question done. That wasn't too bad. Let me just move this one up a little bit. 01. Okay, 8.1.2 is now asking us to find angle O1. All right, which is this angle over here? Sorry, they want us to find angle O1. Okay, this angle over there. Now, guys, if we look at angle O1, like I said earlier, whenever you are trying to find an angle, first look at what that angle is subtended by, which chord or which arc. Now, in this case, chord MN subtends angle O1. Now you're going to check, is there something else that is subtended by MN? Because if there's another angle at the circumference, then we know that O1 is going to be double that. In this case, there actually isn't, right? MN, that chord, only subtends angle O1, so we can't use that. Now we're going to look at O2, right? Can we maybe find O2 in some way? Because if we can find O2, we can just say whatever O2 is, right? 180 minus that, and that will give us O1. Okay, so first step, first thing that you always look for is, does the chord that subtends O1 subtend another angle? If it does, then that's easy to get the answer. If not, you're going to look at the one around it or next to it, O2 in this case. You're going to see, can I find O2? Because if I can find O2, I'm just going to say 180 minus this one. That will give me O1. Now, guys, O2 is subtended by NP, right? Arc NP, right? Do we see that? O2 is subtended by arc NP, right? I'm just going to take that last bit out. NP also subtends R2, right? Do we see, guys? I said this earlier. Usually your answer from the first question is going to have to be used in the next question. And we see that here. Our 21 degree angle that we got here, we're now going to have to use that to get O2, right? R2 is at the circumference. O2 is at the center. They are both subtended by NP. So O2 is going to be double R2. Okay, so let's write that down. O2 is going to be equal to 2 times 21 degrees, which is 42 degrees. Angle at center equals 2 times angle at circumference Right, so O2 is 42 degrees. And now it's easy, guys, because now O1 is just going to be 180 minus 42. Okay, so therefore O1 is 180 minus 42. Again, you don't have to actually write this down. You can just write the answer. But you do need the reason, of course. Angles on a straight line. All right, and 180 minus 42 is 138 degrees. I'm just going to fill that in. Let's take away this dot. 138 degrees. Someone said something there. Let me just go back up. Can't O1 just be R2 times R1? So R2 and R1 is subtended by the diameter, right? And they're not... O1 is not subtended by the same thing. So you can't actually use R1 and R2 together to get O1 in this case. I do have a YouTube channel. Yes, just click the link in my bio and scroll down and you'll get it. We can also use angles in the same segment, both subtended by NP. So angles in the same segment, right, only works if both angles are at the circumference. So if you wanted to use M1, for example, which you could have, right? So you could have used that 21 and that 21. Okay, that would have been a little bit longer, but also fine. So you could have said that M1, because M1 is subtended by NP, and R2, you could have said that M1 is 21. And then these two are chords, or radii, right? So they would be equal. So because that is 21, that would also be 21. And then you could have done angle, sum, and triangle to get 138. That would have been fine. Okay, that would have been a fine way of getting to the answer. So O1 is 2 times R1. No, it's... Oh dear, yes, you are right. Wow, sorry, I didn't even see that. Oh gosh, yes. Who's that? Quacking Clay. Yes, sorry about that, guys. Yeah, actually, that is correct. Sorry, I was missing this for some reason. I wasn't seeing that. Okay, so there's a third way of doing it, which actually would have been quicker. You could say that MN subtends O1 and also R1. Yes, so sorry about that. My apologies. Well done, Quacking Clay, for seeing that. All right, so 138. Either way, doesn't matter which method you used. The answer is 138. Okay, now let's see, what is the next question asking for? Let me just move this up a bit. 8.1.3, M1. Oh, M1 we already got, okay, but we must now just write that down. M1 is equal to R2, there we go, because they are both subtended by this same highlighted arc here at the bottom, right? NP subtends R2 and NP also subtends N1. Because they are both at the circumference, they will be equal. So M1 is 21 degrees. And the reason for that, guys, hopefully you remember, is angle in same segment. So M1 is equal to 21 degrees, angles in same segment. That is the reason we use when the same arc or chord subtends multiple angles at the circumference. Okay, that one wasn't too bad. That was a quick one. All right, now 8.1.4 is going to be a bit longer because we can see that it's a 4-mark question. The other ones were all 2-mark questions. They're saying M2, if it is further given that NO is parallel to PR. Okay, so let's fill that in. I'm just going to take away this highlighted bit so that we can just get some clarity on what's going on here. NO is parallel to PR. So let's fill that in. NO is parallel to PR. Okay, they're wanting us to find angle M2. I'm also just going to take away this circle here. Let me just put that degree back in there. And this circle over here. Okay, so guys, it's good that when you are doing this work and you have your answer book, when you're filling values and stuff into the diagram, do it in pencil so that, like you see now where I had the stuff circled, I could actually erase it. Okay, so it's a good idea to not do it in pen because a diagram like this can become quite busy very easily, and then you might get confused if there's too much going on, so that you can actually erase stuff that you don't need in a question. Okay, they're asking us to find M2, so they're wanting this angle now. Okay, M2. They're telling us that NO is parallel to PR. Guys, obviously we're going to have to use that, right? They're not going to tell us that NO is parallel to PR if we're not supposed to use that. So I'm going to highlight that as well, actually. NO and PR. Right, what do you guys think? What can we do there? We actually have lots of options. We know that that's 90. Okay, so maybe something that we can try here is we can try and find angle P. Maybe we could do that. Right, we have this Z shape over here. Do we notice that Z shape? Let me fill in this line as well. We remember from grade 8, I think, is when you guys learned that the first time, that angles in a Z shape, we call them, or angles that form a Z shape, we call them alternate angles. I see someone said that in the comments already. And alternate angles are equal when they lie between parallel lines. Okay, so that's perfect. So these two lines are parallel. So if O2 is 42, angle P is also going to be 42. Some of you have already said that in the comments. Well done, guys. So angle P is 42 degrees. So now it's easy to find M2. If we look at this big triangle here, right, we have 2 of the 3 angles. So to get M2, all I need to do is to say 180 minus 90 minus 42, and that will give me my answer. Okay, we do have to write this down, guys. We need to say that angle P is 42 and why angle P is equal to 42. Let me just quickly fix this. It's a bit small as well. Okay, so here, sorry, I keep knocking the, the ring light. Okay, angle P is equal to 42 degrees, and the reason for that is alternate angles. Guys, please remember you have to say which lines are parallel in your alternate angles. Reason, you lose a mark if it's not there. All right, so then you're going to say, therefore, M2 is equal to 180 minus 90 minus 42. The reason for that is just angle sum and triangle. And the answer there, 180 minus 90 is 90, and then 90 minus 42 is 48 degrees. Okay. Cool, guys. I'm just going to keep that open so that you can take a screenshot if you want to. But like I said, I will post this on my Google Drive in a little bit. And then the recorded version of this live session will be on my YouTube tomorrow. I will see you again tomorrow at 3 o'clock. Same time, same place. Please follow me if you haven't yet so that you get notified whenever I go live. And yeah, obviously I post a lot of videos that hopefully you guys will find helpful. So please follow. Let your friends know about tomorrow's live if they maybe weren't able to join now. We're going to do some more circle geometry. We're going to do the other circle geometry questions in this paper, which is the May-June 2021 paper. There was one more question. And then we're going to do the November 2020 paper after that. All right. Thank you so much, guys. I hope that you enjoy the rest of your day. So Boipelo, I just said it's going to be this one, May-June 2021. I think it's question 9, and then the November 2020 circle geometry papers or questions. All right. Thank you, guys. Enjoy the rest of your day. Thanks again for joining.